Selecting the appropriate conduit for bridge installations is crucial, hinging on the bridge's specific needs and its surrounding environment. Steel conduit presents a robust and enduring solution, effectively safeguarding cables and wires against potential damage. Its inherent resistance to corrosion and ultraviolet rays renders it particularly well suited for outdoor environments. PVC conduit stands out as a lightweight and cost-effective alternative, streamlining the installation process. Its resilience against moisture and chemical exposure makes it viable for both indoor and outdoor deployments. Fiberglass conduit offers a blend of strength and lightweight properties, coupled with resistance to corrosion and ultraviolet radiation. This combination makes it a preferred option for outdoor settings where aesthetic considerations hold importance. Aluminum conduit distinguishes itself through its lightweight nature and resistance to corrosion. Its non-magnetic characteristic positions it favorably for use in areas sensitive to magnetic interference and finds frequent application in marine environments. The optimal conduit choice for a given bridge project depends on a constellation of factors encompassing the bridge's dimensions, the environmental context, and the nature of the cables and wires to be accommodated. Seeking counsel from a qualified electrician is paramount to ascertain the most appropriate conduit type tailored to the specific demands of the project. Now, let's delve deeper into each type of conduit, exploring their properties and applications in more detail. Firstly, steel conduit. Renowned for its high strength and durability, steel conduit offers exceptional protection against physical damage, including impacts and crushing forces. It is commonly used in exposed locations where cables are susceptible to mechanical stress. Steel conduit is available in several types, including rigid metal conduit, intermediate metal conduit, and electrical metallic tubing. Rigid metal conduit is the thickest and heaviest type of steel conduit, providing the highest level of protection. Intermediate metal conduit is thinner and lighter than rigid metal conduit but still offers good protection. Electrical metallic tubing is the thinnest and lightest type of steel conduit, suitable for use in concealed locations where physical protection requirements are less stringent. Steel conduit is typically galvanized to protect against corrosion, but it can also be coated with other materials, such as PVC, for added protection in corrosive environments. Secondly, PVC conduit. Made from polyvinyl chloride, PVC conduit is a non-metallic conduit that is lightweight, flexible, and easy to install. It is resistant to corrosion and chemicals, making it suitable for use in a variety of environments. PVC conduit is commonly used in underground applications, as it is not affected by moisture or soil conditions. PVC conduit is available in several schedules, which indicate the wall thickness of the conduit. Schedule 40 is the most common type of PVC conduit, suitable for general-purpose applications. Schedule 80 PVC conduit has a thicker wall and is used in applications where higher strength is required. PVC conduit can be bent using a conduit bender, allowing for easy installation around corners and obstacles. Thirdly, fiberglass conduit. Composed of glass fibers embedded in a resin matrix, fiberglass conduit offers a unique combination of strength, lightweight, and corrosion resistance. It is particularly well suited for use in harsh environments where steel conduit may corrode or PVC conduit may become brittle. Fiberglass conduit is non-conductive, making it a safe choice for electrical installations. It is also resistant to ultraviolet radiation, ensuring long-term durability in outdoor applications. Fiberglass conduit is commonly used in chemical plants, wastewater treatment facilities, and other industrial environments where corrosive chemicals are present. Fourthly, aluminum conduit. Known for its lightweight and corrosion resistance, aluminum conduit is a popular choice for electrical installations in marine environments. It is also non-magnetic, making it suitable for use in areas where magnetic interference is a concern, such as hospitals and research facilities. Aluminum conduit is available in both rigid and flexible forms. Rigid aluminum conduit is similar in construction to rigid steel conduit but is much lighter. Flexible aluminum conduit is used in applications where flexibility is required, such as connecting to motors or other moving equipment. Aluminum conduit is typically coated with a protective finish to prevent corrosion, especially in saltwater environments. In addition to these four main types of conduit, other types of conduit may be used in bridge installations depending on the specific requirements of the project. These include flexible metal conduit, liquid-tight flexible metal conduit, and high-density polyethylene conduit. Flexible metal conduit is a flexible type of conduit that is used to protect wires in tight spaces or where movement is required. Liquid-tight flexible metal conduit is similar to flexible metal conduit but is also liquid-tight, making it suitable for use in wet locations. High-density polyethylene conduit is a type of plastic conduit that is used in underground applications, offering excellent resistance to chemicals and moisture. When selecting conduit for a bridge installation, it is important to consider the following factors. Firstly, environmental conditions. The conduit must be able to withstand the environmental conditions in which it will be installed, including temperature extremes, moisture, and exposure to chemicals. Secondly, mechanical protection. The conduit must provide adequate mechanical protection for the wires and cables it contains, protecting them from damage due to impact, abrasion, or crushing forces. Thirdly, corrosion resistance. The conduit must be resistant to corrosion, especially in marine environments or areas where corrosive chemicals are present. Fourthly, electrical conductivity. The conduit must be electrically conductive if it is used as a grounding conductor. Fifthly, ease of installation. The conduit must be easy to install, minimizing labor costs and installation time. Sixthly, cost. The conduit must be cost-effective, balancing performance with budgetary constraints. In summary, selecting the appropriate conduit for a bridge installation requires careful consideration of the environmental conditions, mechanical protection requirements, corrosion resistance, electrical conductivity, ease of installation, and cost. Consulting with a qualified electrician is essential to ensure that the selected conduit meets the specific needs of the project and complies with all applicable codes and regulations.